Hi, Amy. How are you doing?
Hi, sir. I'm good, thank you. How are you?
Very good, very good. So, finally, you're now in year 13, right? How did year
Yes.
12 go for you?
It's been a bit of a roller coaster ride, especially with like the COVID and everything, staying at home, going to school, and all the restrictions, and not many tests as well, which is not really normal because we usually have regular assessments, which should be done, but didn't get to do. So, yeah, I've kind of been doing like a lot of self-assessments for myself and trying to see where I am. But yeah, my mock results went all like I thought to the best of my ability, and then I guess towards the couple of end of the weeks until the summer ended, our teacher picked up on the main thing that our whole year group found difficult, and that topic was like mechanics, especially on that side with like variable acceleration, pulleys, forces, things like that.
Yeah, yeah.
Um, so yeah, I had a couple of exam questions that I just thought would be helpful if we could just quickly run through it in
Sure,
terms of
sure.
methods and yeah, working
So,
out.
mainly mechanics, you mean, right?
Yeah, yeah.
Perfect. So, let me share the screen with you. Yeah, and then you can share any kind of questions which you have and which you want to work with, right? And let us see how I can help you out in that. So, you
All
can
right.
share the
Thank you.
question. We'll
Yeah.
discuss how to work, okay?
Okay. Yeah. Can you see my screen?
Yes, I can. Yeah, yeah.
Yeah. Cool. Yeah. So the first one was question two. It was 2B, but since it's like a thing, I guess we'll work through it from
Sure,
part A
sure,
as well.
sure, sure.
Yeah.
Can you please read the question?
Yeah. So a bird leaves its nest at time t=0 for a short flight along a straight line. The bird then returns to its nest. The bird is modeled as a particle moving in a straight horizontal line. The distance s meters of the bird from its nest at time t seconds is given by s equals a tenth t to the power of 4 minus 20 t cubed plus 100 t squared, where t is between 0 and 10, both included.
Correct.
Um, A, explain the restriction t
Yeah,
between 10 and, yeah.
yeah.
Yeah, so that one was actually fine. I just, what do I do? So t to the power of 4 minus 20 t cubed plus 100 t squared. I factorized it, and then when I got my two factors, I got t minus 10.
So
So
we'll write
t,
down the factors. We'll write down the factors here, right? So you got s equals to 1 over 10. The first you factor was t square, correct?
t squared, yeah,
And
t
then we
squared
have minus
minus
20t plus
plus
100.
100, yeah,
Yeah. Then you factor it further, correct?
yeah.
What do you get?
T squared, then t minus 10 whole squared.
Correct. That's the factored form. Now, explain the restrictions 0 to 10.
So I just said, so t squared just shows t could equal 0 for the equation to be true, because at when time is 0, that means the displacement that would move would be 0.
Yeah.
So then it's either t is 0 or t is 10
Yeah, seconds. And time is in seconds.
seconds.
This is
Yeah,
measured as in meters as given here, correct? Part
right.
B.
Yeah. Part B. Find the distance of the bird from the nest when the bird first comes to instantaneous rest.
Correct. So that means what? If you look
Uh,
at this function, can you sketch this function?
yes.
Yes, try to sketch it. That will
So
help.
you have t on the x-axis, so 0 and then 10, and then you should have a quadratic little curve at the 10 part.
Yeah. So basically, the bird goes like kind of like this, right? And then kind of like this. Do you see that?
Yeah,
Because here also it is t square. That means the curve was kind of like this. But we are not uh, thinking about what happened before, correct?
yeah. You can't have
That
negative
becomes a
time.
quadratic equation itself, correct? You get
Right.
an idea, right?
Yeah, yeah.
So this is how we should visualize. This first thing is to visualize what we're trying to do, correct? Now the question is, find the distance of the bird from the nest when the bird first comes to instantaneous rest. What does that mean?
Velocity is 0.
Velocity is zero, and velocity is the tangent, correct?
Yeah.
So on this curve, which is displacement, tangent will be 0 at this point. Is that clear to you?
Right. Yeah.
So you have to differentiate the equation and find when is it 0, right?
Oh, see, I did it, and then I was wondering. So I got two answers as t is. So when I differentiated, I got t as 0,
Yeah,
5, and then 10.
yeah, yeah.
But
So,
I didn't know because I didn't graph it. I thought, why can't I use 10?
okay, okay, okay.
So yeah, that makes sense. So I just need to sub in t equals 5 into the equation and then get it.
Yes, yes,
Oh,
yes. You get the idea.
okay.
But
Yeah,
when
yeah.
you're doing this particular thing, right, and real life application, it is a good idea to sketch. Once
Yeah.
you sketch, you get an idea like how everything is flowing and what are we looking for.
Right, right. Yeah.
It makes sense because we have order 2 0 here, order 2 0 here. It becomes a quadratic equation as explained there, correct? Now,
Oh,
you could also directly find the derivative of this equation right from there, right? Because without going into that product rule, right? So we can write this as 4t cubed minus
minus
60t
60.
squared
Yeah.
plus 200, right? T. Is that clear?
T. Yeah.
And you could also work with this equation. You could. I mean, either way you could work. But anyway, you already got the values of t. So you know the times when the instantaneous velocity is 0. It's a
Right.
turning point. So basically, it is always a turning point. So you're basically looking for the turning points in this particular equation, right? Turning
Yeah.
point 1, turning point 2, when the velocity is equal to 0. Is that clear to you?
Yeah.
Okay, now,
So it's all about the sketching. Okay.
yeah,
That would have saved me a lot. All right. So yeah, that question's fine.
yeah, right.
Um,
I'll clear this and we'll move to the next one.
all right.
Yeah.
Yeah. So question 4.
Mm-hmm. Can you
Um,
please read this one also?
yes. So a particle P moves along a straight line in such a way that at time t seconds, its velocity v meters per second is given by v equals half t squared minus 3t plus 4.
Correct.
Find A, the times when P is at rest, and part B, the total distance traveled by P between t equals 0 and t equals 4.
Correct. So at rest again, at rest means what for you? In this case,
Um,
rest means velocity
V
is 0,
is
right? So
0.
let's
Yeah.
factor this. Let's factor this. So when you factor, what do you get?
Um,
4 times 4,
I
right?
t minus 4 and t plus 2,
1, 1.
1.
4 times, sorry.
2.
Oh, sorry, sorry. How? Oh, sorry. Wait, wait, wait. I cannot erase this. um, let me do like this. So when you do half as a common factor, then we get t square minus 6t, right? Plus
Mhm.
8, plus 8. Let's go like that. Is that clear? So now we get half of, this is 8 is 4 times 2, right? And both negative, t minus 4 times t minus 2. Is that clear to you?
Yeah.
So that is your factored form, right? Let us go in steps. Otherwise, if we jump to the answer, you might do a mistake. Right? So we got this particular equation, and clearly, when the question is times when P is at rest, P is at rest means velocity is 0, right? So
Right.
if we're looking for velocity equals to 0, and velocity is 0 at t equals to 4
2
and t
seconds
equals to
and
2.
4.
Of
Yeah.
course, you write 2 first. You're right. So
Well,
that is
it doesn't
how it
matter, but yeah.
Hmm.
Yeah.
So that is right. If you look at the sketch, as I was emphasizing on earlier, we have this particular parabola kind of thing because t square minus this, and factored form means 2 zeros. And clearly, we are looking at when t is 0, we have 4 as our point. So kind of like this, right? So this is the time t and this is the velocity which we have already sketched, and the 2 points of our instantaneous velocity being 0 are at 2 and 4 as shown here. Is that clear to you? So
Yeah.
you kind
And
of
then,
have a rough sketch of what we are looking into. Now,
yeah.
let's answer the question. The total distance traveled by P between t equals to 0 and 4. That means distance along this time, right? How will you do this part?
I was thinking, so when I did it, I integrated the velocity to find the displacement.
Correct?
And then when you do with integrals and you put like 4, 0, because that's the difference between the times, and then you
Yes.
just subtract. I don't know if it's a method error, but I didn't get it right. So
Yeah.
yeah.
I will
Is
tell
that
you what mistake. I will tell you what mistake you could have done. I'm not sure about it. Do you
oh,
see this is the negative part?
but the area should be positive.
So you have to do three parts of integration. So first integrate between 0 to 2, right?
Oh,
And then make negative of the other one because that should be added. Distance is a scalar quantity. You cannot,
right.
you'll get a negative answer. So integrate from 2 to 4, but with a negative sign here, right? So when you
Yeah.
do this, then you get the correct answer.
So um, okay, so we're doing 0 to 2, which
Yeah,
is positive.
positive, yeah, which is positive.
But when you do 4, between 2 to 4, we get a negative value. So you're putting a minus to compensate and make it an add.
Perfect, perfect. Then you get the
Oh,
right answer. You get the
right.
answer. Simple
Yeah, I didn't
mistake.
do that.
Yeah,
Okay.
that will help you to get most of the questions right. If so, look at the graph. That is why the graph was very important, right? You can visualize and see, well, this is negative part. I should flip it and then add because we are talking about distance, not displacement. What you
Right.
found was displacement. Do you understand?
Oh, because distance is a scalar, so you can't
Yeah.
have negative, whereas
The question
displacement you
was
can have negative.
distance.
Oh, okay. So it's two things. First, I need to graph, and second, I need to read the question whether they're talking about displacement or distance.
Correct.
Okay,
Right. So
got
that's
it.
one part, right? Now,
Yeah.
let me explain you the other way also, because in the first question, I also saw. Can you please again read the question?
Yep. So a particle P, it moves along a straight line in such a way that at time t seconds, its velocity v meters per second is given by v equals half t squared minus 3t plus 4.
Correct. So, actually speaking, when they say along a straight line, it means what? Think as if this is a road, right? And you just started from somewhere. In this case, it is definitely starting 4 units away with velocity something, right? So, let us say, let me just start from somewhere. The velocity is positive. You're going like this, right? Initially, t is 0, v is positive, correct?
Yep.
So, at this point, it actually turns. Do you see that turns? And then it might go up again, I don't know. But what I'm trying to tell you is in this case, we are only going up to this place. Just forget about it. It's a parabola. So it'll keep
Hmm.
going. So we first find the turning point.
Yep.
Correct? So once you find that turning point, it will turn there also. There are two turning points. First turning point we found is at t equals to 0. The second turning point we find at t equals to 4.
Right.
So what you could do is that you could find the distance s1, which is from t equals to 0 to 2, right? And then
Yep.
you can find S2 as the distance from 2 to 4.
2 to 4.
And then
Yeah.
you could add S1 and S2.
But how do you find that? By integrating, or?
Okay. So, yes, better,
Oh,
yeah, better is still by integrating.
no,
Yeah,
no, no. I
you
mean,
have
with your method, how do I find the distance by looking at that graph?
okay. So, at two different times, you have two different velocities.
Right.
So, you can find S using your formulas which you learned earlier, v square minus u square equals to 2as and all those
Oh,
formulas, right? You could do that. So you could use those formulas to also calculate individual distances and then add it.
oh, right. Yeah, yeah. I
You get
understand.
the idea, right? You could do
Yeah.
that, but not for you at present. But this is like kind of showing you what does this mean along the straight line. When
Mm,
you're making in 2D, I mean, in a plane, I'm actually sketching like what, right? I'm saying velocity is this, right? I'm saying
yeah.
velocity is this. If I have to find the distance, then distance curve will be kind of will start from, let's say, some place and will go like this, correct?
Right.
That is how the distance is going to go, whether the velocity is negative or not, right? We are talking about distance, not displacement, correct?
Yeah. Yeah.
So that is how the distance is going to go. So that is how you look. But when we say a particle is moving along a straight line, you have to think like a highway going from, let's say, north to south or south to north, right? So we are
Hmm.
moving along this highway. As soon as the velocity is negative, we turn the direction from north to south.
Oh, yeah.
So let's say you go 100 kilometers north and then you take a stop there, or like just take a U-turn and come toward that. U-turn is the point of instance zero velocity.
Oh, turning point. Yeah, got it.
That turning point, I was saying, this is your turning point. You see that? This
Yeah,
is the
yeah.
point of but when you turn, displacement decrease, but distance is increasing all the way, right?
Right, right.
100
Yeah,
kilometers up, 50 down. Oh, you travel 150 kilometers.
yeah. But your
Displacement
displacement could end up
was
being zero.
50 only, right? Yeah, could be
Right.
much lesser.
Oh,
So that
okay.
is the whole thing which you have to keep in mind. But
Yeah.
integration takes care of all those things, right? But
Oh, I see.
you have to still understand your science, right?
Yeah, that
So,
makes sense.
otherwise, you can integrate from 2 to 4, but write an absolute value. Do you understand? Because you can write here, even if you get a negative answer, whatever function of time you have here, right?
Yeah.
So put an absolute value. Don't put any negative values. Then you can add.
Oh,
So you can
yeah.
add from 0 to 2, but put an absolute value. Even if it is negative, you are taking care of it by making it absolute value. So this is the
Oh,
easier solution.
yeah, yeah.
Then you don't have to graph, but you need
Makes
to
sense.
find
Okay.
you have to find the turning points, because turning points will really decide what is the interval.
Right, right.
Your
Yeah,
question is
because
helping you out by finding
because
the turning point. If
yeah,
part A is not given to you, still you have to do it.
yeah, and yeah, and if A wasn't given, I could fall into the trap of doing just between four and
Yes,
zero without seeing
correct,
the two. Yeah.
correct. So
Oh,
normally your papers, I like your papers because they actually
they help you.
systematically help you, right?
Yeah, yeah, that's
Oh,
true.
my question will not have part A. They're
You
gone.
let us fall into the trap.
Yes.
That's better. Okay, yeah, makes sense now.
So
Okay,
yes, that's
thank you,
absolutely
sir.
clear, right?
Yeah, yeah, absolutely clear. So in both those questions, I realized I need to graph. I always graph, but just for these ones, when I think mechanics, I just don't think of graphing, only for pure. So I feel
Mhm.
like I need to start graphing because
Yes.
that's a really important part. Okay, question 5,
Mhm.
part C, but we
Okay.
can just go through them.
Okay,
So
sure. Read.
okay, so a particle P moves on the x-axis. At time t seconds, the velocity of p is v meters per second in the direction of x increasing,
Mhm.
where velocity equals 2t squared minus 14t plus 20, where t is greater than or equal to 0.
Correct.
Find the times when p is instantaneously at rest.
Correct.
Part B, the greatest speed of p in the interval where t is between 0 and 4, and then part C, the total distance traveled by p in the interval between 0 and 4.
Very good. So what will you do? Tell me your strategy now.
Okay, so now that I feel like these questions are exactly like the ones we just went through, but sure. So when it says instantaneously at rest, it means v is 0. So we just have to factorize that
Correct.
quadratic,
Correct.
which is I got, yeah, we can work in steps.
So do it in steps, right? First thing, right? Maybe
So
you may think it is very easy, but still do it in steps, right? It is
yeah,
never, it is useful.
yeah, because
Simple.
I can always go back and check if
Yes.
it's laid out nicely. Yeah.
Correct. Correct.
So the 2 times is t equals 2 seconds and t equals 5 seconds.
Yes. Then
Then
what will you do after this?
I will graph it.
Yeah, you'll grab it. So 20 is when t equals to 0. So just start. It is all rough sketch. You know nothing. It doesn't take time. Just sketch.
Yeah.
Simple as that. You don't have to be accurate. But just say, well, this is 20 for me. And the two zeros are at 2 and 5, correct?
Right.
Got it. Now you've done the first question, which is we know the times when it is at rest, right? T in
Yeah.
second, we know it. And this is displacement, it is velocity in meters per second, right? Okay. Fine. Can you answer the second question?
Yeah. So okay, this was actually surprising with this question. So as you can see, the number of marks is 5 marks,
Mhm.
but for this question, I did actually end up graphing it. And just by looking at the graph, when they said in that interval between 0 and 4. Just looking at the graph, you can see around 4 seconds, it goes like below the x-axis. So the greatest speed has to be 20, but it's 5 marks, so I needed to show working out. So I only got, even though my answer was right, I only got 1 out of the 5 because I didn't show any working, but I didn't really know. Do you
I,
see? I thought I could just do it graphically, but I couldn't.
I will tell you the key parameter which you did not use in your answer, and therefore you did not get, you got 1 out of 5. You
Yeah.
know why?
Why?
It is a boundary condition. So you must have, you remember the rule which you learned, that whenever you have a boundary condition,
Yeah.
then you have absolute maximum or minimum value. So in this interval, our boundary is at 0 and 4, correct?
Right.
Our maximum value could be at f of 0. You have to show this word at f of 4, and where the derivative became 0, the critical number. So you have to find the critical number, and then you have to see what is f of c equals to. If there are more than one critical number, then you have to find the value at all those critical numbers.
Oh,
And once
I
you
see.
find the value, you have to compare. And when you compare, you find that, well, 20 is the maximum value, and that is my answer.
Oh,
Every step is giving you 1 mark, leading to 5 marks. You
yeah.
did only step number 1. You said your graph is decreasing.
Yeah, that's true. I realized that was the issue. No, but I did try and I started actually finding the differentiating.
Correct. You
I don't
found a
know.
critical
So
number.
yeah, so I
Did
did
you
try
write?
and find the turning point, and I
Yes.
got that as like 7/2. But
Okay.
then when I put it back in, I'm getting like a negative number.
Yeah. Yeah. But remember, no, 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 no. It is the question of speed. So negative is
Yeah, I got negative
absolute
speed.
value. Negative number, you have to consider positive because it is not velocity. It
I'm
is
so done with all
speed.
these scalar and vector quantities. I can't. Okay. So
Speed.
I
You
need
have to make it
absolute
positive.
values.
Yeah, yeah, yeah. Positive value. So you have to put that value at critical number and check the speed and make it absolute value. So remember absolute value while you are doing this. Is that okay now? I think
Yeah,
that
yeah.
solves many of your questions
Issues.
why
Yeah,
they were going wrong. Do you understand?
yeah.
Absolute function. So make it positive when we are talking about distance. It is scalar quantity.
Oh,
Speed, scalar quantity. Don't go with the sign.
right. Okay.
Absolute value. Okay.
Yeah.
That should help you, right? Now, the third point, the total distance, there are turning points here, right? At 2 and 5. So you'll integrate between three limits, correct?
Yeah, so
Oh.
0 and 2.
And 2 and 4. It's only going up to 4, correct? 2 and 4.
Oh, so again, that was the same issue. I did between 4 and 0, and then
Yeah, that's
lost
wrong.
a value. Okay, got it. So makes sense.
Correct.
So I can see a bit of a running theme. At least I know where I was, the exact point I was falling.
Yeah. Well, that's very interesting and useful to understand, and for
Yeah,
me
for
also
sure.
the learning thing. Oh, this is actually speaking, sharing from my experience. This is where most students go wrong, right? So it is not a new thing.
Oh, I see.
Yeah.
Okay,
Yeah.
cool. At least I'm not alone. All right. Question 15B. Oh,
Okay.
all the way to 15.
Okay. Go.
Okay.
Correct. Can you please read the question?
Yeah. So a particle P moves along a straight line. The speed of P at time t seconds, where t is greater than 0, is v meters per second, where v equals pt squared plus qt plus r, where p, q, and r are constants.
Mhm.
When t is 2, the speed of P has its minimum value. When t is 0, v is 11, and when t is 2, v is 3.
Correct.
Find the acceleration of P when t is 3.
Correct.
And part B, the distance traveled by P in the third second of the motion.
What is the meaning of the third second? Tell me first that. What do you understand by third second?
So if they said like first second is between 0 and 1, then the
Correct.
second second is 1 and 2. So then third second is between 2 and 3.
Perfect. Between 2 and 3. That is perfect. Now, they are given the equation, which is v equals to pt square. Let's write down, plus qt. you have to find these three unknowns, which is P, Q, and R, right? And of
Yeah.
course, you are given the condition that when t equals to 0, speed of P has its minimum value, right? That means the derivative is 0 at that point, correct? At t equals to 0. So if you find the derivative of this function, we get 2pt plus q, right? And we
Hmm.
know that if t is 0, then this has a minimum value. That means at t equals to 0, at t equals to 2, we get a 0, right? So that means at t equals to 2, the derivative is 0, right? Minimum
Yeah.
is when it's a critical number. So that gives you one equation, and that clearly indicates that if I substitute t as 2, and you get 0 equals to 2 times 2 for t, p times 2 plus q, right? So I get one equation which is 4p plus q is actually equal to 0. Is that clear?
Yeah.
So that becomes one of my equations. Now it also gives me two other conditions. When t is 0, v is 11. So when t is 0, v is 11 clearly indicates that r is equal to 11. Is that clear to
Yeah.
you?
Yeah.
And when t is 2, v is 3. So we know the value of r. Now you plug in 2 for t and 3 for v, right? So we get 3 equals to, when you put 2 here, 2 square is 4p plus 2q, and we know r is 11, right? So we get one equation right there, right?
Hmm.
Which is bringing it on this side means 11 minus 11 plus 3 is minus 8, and 4p plus
4p.
2q, and you can divide this by 2, so minus 4 equals to 2p plus q, right?
Yeah. And then you have
But
your other equation,
you have these two equations, correct? 2p,
simultaneous. Yeah.
4q, just take away one from the other, right? So if you take away this from that, 4 minus this is 2p, right? And 0 minus this is 4, so p is equals to 2, correct?
Yep.
So when you plug in p as 2, you get q as equal to 2 to 8 and minus 8. Is that clear to you?
Minus 8. Yep.
So you get all these values. So you have your equation. So write down your equation now.
So
Velocity is what?
v equals 2t squared minus 8t plus 11.
Correct. So we'll just clear all this and we'll write down v equals to, tell me again.
2t squared
Yeah,
minus 8t plus 11.
that becomes your equation. Now let's
Yeah.
work on it. Find acceleration for p when t is, now is very simple, right?
So you just differentiate.
Yeah,
Yeah.
4p minus 8.
It was
And
part B that I
again,
found a bit tricky, but I thought we'd work through it.
correct. So we get
Yeah.
this acceleration as equals to 4 meters per second square, right?
Perfect. Yeah.
Right. Now this is done. Next part. The distance traveled by p in the third second, right? So now you can do the integration part, but you need to first differentiate your equation itself and see, is there a turning point in between 2 and 3? Whether
Uh,
it is positive or negative.
yeah. See,
Which
I
is
just
preferable?
jumped straight ahead and I just integrated it and then between 3 and 2 and then just solved and then got the wrong answer. So I
Yeah.
didn't consider a turning point.
Yeah, you have to consider, you have to factor this, correct? So
Yeah.
22 and what, so that is another tricky part here, correct?
Oh,
Hmm.
I didn't know. Okay. Oh, okay. So wait, what? So what am I supposed to? So I just so you can't just straight away integrate the 2t squared minus 8t plus 11.
You have to find the turning points. If you
Oh.
do not have a turning point between 2 and 3, it is clear you'll get the right answer. What you did. Since you did not get a right
Oh.
answer,
So there was turning points. Okay.
there is some
And then
part
that means you have to do
negative.
it individually.
Some part is negative out of this.
Oh.
They have purposely given you that particular part, right? So you have to factor this.
Okay. Well, okay, I can do it now. So yeah, I just needed to know that.
Correct?
Oh, it's so tricky like that. Okay.
Yeah, they are very tricky questions. They look simple.
Yeah.
They're not.
They're not. Okay. Thank you for that. So that one makes sense. And then 16. That's the last one. Yeah.
Okay. Okay, good. Read the question.
Of this paper. Okay.
Oh, you got many of these papers.
Oh, I've just got one pulley one
Okay.
and one other one. Yeah.
Okay. And
Okay. So question 16. Unless otherwise indicated, wherever a numerical value of g is required, take g as 9.8 meters per second squared, and give your answer to either 2SF or 3SF. Okay.
Or okay. Continue.
So a particle P moves along the x-axis. At time t seconds, where t is greater than or equal to 0, the displacement is x meters of P from the origin O is given by x equals half t squared, and then in brackets t squared minus 2t plus 1. And then part A, find the times when P is instantaneously at rest. Part B, find the total distance traveled by P in the interval between 0 and 2. And part C, show that P will never move along the negative x-axis.
Correct. It's always
Okay.
okay.
Yeah.
So first thing first, we'll just factor this, right? X equals to t square is already there, and this is what? This is t minus 1 whole square, right?
Yep.
So you have two zeros. One is at 0 and the other one is at 1, correct? So these are at zeros. Zeros are at 0 and at 1, correct?
Yeah,
So,
but this
yeah.
is
Now, what is this?
displacement.
A particle, this is displacement. A particle P moves along this at this time. The displacement S is given to you. I should have written X there, but we'll write displacement, right? Displacement is given to you. And this is the turning point, and this one is also a turning point at 1, correct? So basically, what
Yep.
is happening is we'll go with dotted line here, and then we'll go like this, correct? Is that clear to you?
Yeah.
This point happens to be at 1. Is it okay? So
Mhm.
So one thing very clear, it didn't go, this is a displacement which is positive, right? Find the times when P is instantaneously at rest. So that means we are looking for the turning point, right?
Mhm.
So displacement, we'll do the derivative of displacement to get the velocity.
And then make that equal to 0.
So velocity will be, you can always differentiate this, and then you'll get this particular point, correct?
Yeah. So I got t as 0, half, and 1 when I did that.
0, half, and 1. Okay, that's
Yeah.
fine. 0, half,
Okay.
obviously, you're right. So this point is half for you. And this is also a turning point. We can already see 0 is also answer, 1 is also answer. So you got
Right.
half. That's genuine, right? So you got these three turning points. So that is correct. Find the total distance traveled by P in the time interval 0 to 2. Now we are again talking about distance and not the displacement.
Displacement.
Right? Anyway,
Yeah.
so but anyway, in this particular case, I think area under the you have to find. So you find how much up you went. Basically, you went up, right? Maximum,
Yeah. Yeah.
and you came down, minimum, right? So between then you went up. After that, you are going up only, right? Do you see that? So
Oh.
basically, in this part, you have to find the time half. What is the maximum distance? So plug in half here. So find x equals to replace t with half.
Yeah. And I got. Oh.
You
I
get
got.
my point?
Yeah. So you're putting half into the displacement
T.
formula.
Yeah, you find the maximum height. Do you get the idea? So you find this distance going up, right?
Okay. Wait.
So
Should I
x max,
plug
x
in the
max.
calculator?
Yeah, and multiply by 2 because you came down the same distance. So from 0 to 1, you went up and you came down. You will not integrate this because you have to integrate velocity to find displacement.
Oh.
Displacement is given to you. You are finding turning point. So distance, you went 100 kilometers, you came back 100 kilometers, 200 kilometers, not 0.
Oh. Yeah.
So find the maximum, that is the turning point, displacement, and then add the same displacement because you came to
Coming
0.
down. Yeah.
So twice the maximum distance is your distance traveled in the first second, 0 to
Oh.
1.
I didn't times it by 2.
Yeah, after that it is only increasing. Then
Right.
after that you can calculate and then put t equals to. So
2.
you have to find, so you have to find what is s at 0, what is s at half, correct? What is s at 1? What is s at 2, right?
Yes.
and add all the absolute values, distance between the two, right? Do you understand?
Yeah,
This
yeah,
minus this minus this, and this minus this are the distances, correct?
yeah.
Add them, absolute values, get the total distance.
Oh, got it. Yeah.
That is how you do. So you have to see which variable you're working with. If you're working with distance or displacement, no integration.
Yeah. All right. Okay. Yeah, it was just that idea of, like you were saying in the beginning. So your displacement, let's say if we went from here to here and then back, your
Yeah,
displacement 0, but the distance you covered is you still
double.
covered it. So it'd be double. Yeah.
Yeah,
All right. Okay. So is that what the graph showed by going up to the turning
yeah,
point
yeah.
and then
Yeah.
coming back
The
down?
graph, when we showed like this, we are saying, well, I'm writing dotted here. Well, you go like this, come back, and you go like this, correct? So
Yeah.
that means we need to first add this much. We went up, right?
Yeah, that part.
And
Okay.
then up to here, we came down that part, correct?
Oh. So it's literally showing.
So yeah,
Okay.
this is S1, which I should write half because this is distance at
Half.
minus S0, right? Do you understand?
Yeah.
And this one here, when you travel this distance, it is S of 1
S1
minus S of half,
minus
correct?
half. Yeah,
Absolute
yeah.
values.
Yeah,
Absolute values.
yeah.
And
And
this
then you
one
add those.
is SS2 minus SS1 absolute value. So
Oh,
displacement difference, add, keep on adding them.
makes sense, makes sense. Can I just quickly take a picture of
Yeah, sure, sure.
so the graph is literally showing that, which is so great.
Yeah.
Okay. So cool, thanks. Right. Yeah, that makes sense.
Yeah.
So yeah, part C.
Yeah.
Show that P will never move along the negative x-axis.
Yeah, because the way it has gone here. So it is always above the curve because
Yeah.
the graph which we showed, so distance is, as you can see from here, it is always going, right?
But how do I? So
Because
when they say show that,
X,
can I do it
this
graphically?
is this is X, right? So they have actually put X here because they are using the variable X for displacement. You get my
Yeah.
point.
Yeah.
And here is time t, correct? So as you can see from the graph, it is non-negative. Do you see that?
So can I just say, so for that question, can I just draw the graph and say from the graph it shows that it's never
Oh,
below
okay.
the x?
There's another way. Just a
Oh,
minute. We have x equals to half of t square, and we have t minus 1 whole square, right? So
yeah.
both are positive, right? Both are always positive. So
Oh,
this is
so the
always greater than
squaring.
equal to 0.
Oh,
So you can
actually,
make
I think that's the one that was in the mark scheme. Yeah.
so you can make this inequality. And so this is always a non-negative function. So use
Oh,
the
okay.
word non-negative.
Do you think we can show it by doing it like just showing the graph, or do you
Yeah, yeah.
think
Yeah,
you
but
have to do it?
but I think algebraic expression is better in this
Oh,
case.
right. Okay.
You have already factored, you've seen that both
Yeah.
each and every term is positive, right?
Yeah. Yeah. Makes sense.
Non-negative, I should say, because they can be 0.
Yeah.
Yeah.
Okay. So that was all for that section of like variable acceleration.
Excellent questions, Amy, I should say, because these questions are very, very, very thoughtful questions. And if you
Yeah.
don't really widen your thinking, right?
Mm.
If you quickly jump into conclusions, like speed, right?
Yeah.
The speed, not negative number. You cannot say, well, that was 20. It has to be the highest number. No, no, no.
Right.
You could have minus 25. Who knows? Calculate and check. That
Yeah.
minus
Yeah.
25 absolute value it could be higher than 20.
Right. Yeah. Yeah. Because
So,
it's a scalar quantity. You have to
yeah.
take the absolute value. Oh, I see. Okay. Okay, that makes sense. So
I liked your
those.
questions. I liked your questions. Yeah.
All right. Yeah.
That
I'm
was
glad
that was
to.
actually amazing. I really liked it, and I hope you learned from it. Right? Did you
I
learn?
learned so much. Oh my god. So like while we were going through it, I can literally tell you right now everything I need to work on.
Mm.
So when it says with questions, after you maybe work out or factorize something, you always draw the graph. And
Correct.
then when you draw the graph, whether it's like displacement over time or velocity by time, the graph will show you turning points and everything, which is so easy to like figure out. And then from there you have to read the question. So if it's saying displacement, you know you can have negative numbers. If you have scalar quantities like speed and distance, you have to take the absolute value, which is where I fell in the trap, especially with the integrals. And then when you have to integrate, if you have turning points, you can't just find it from the intervals. You have to include the turning points and do it separately like this.
Yes, yes.
So yeah.
Perfect. So that was amazing. Even I like this experience of learning with you how to, sometimes students get into trap, how to pull them out
Yeah.
from
That's
the.
what you're there for, sir, to help me get out of the trap.
Great.
Yeah.
So we're going to end this session here, and next time
Okay.
come with more questions, and let us see how it goes. I'd like you
Okay.
to
Yeah.
share with me in advance what you're going to learn, so that I could also prepare something which, in addition to your examples, I could provide you with some examples. That could be of
All
some.
right.
Okay.
Okay.
So we'll
Yeah.
do that from next time. Okay. Is that clear?
Yeah. Yeah. Clear. Thank you so much, sir. I
Thank you.
appreciate all your help. Thank you.